Hello guys, my name is Desmond and I welcome you to my lesson for today. Ladies and gentlemen, please do allow me to say it's very much important that I say it's very much important, ladies and gentlemen, because what I'm about to say is massively important. Guys, a day without learning something new, it's a day wasted. By so saying, good people, please make sure that by the end of each and every lesson that I conduct, you learn something new. So guys, without any waste of time, as you can see over there, I've got a summary of all that I want to discuss under that chapter of momentum. So ladies and gentlemen, please do make sure that you've got something to write and again a glass of water, okay? Because I'm assuming we're going to have an interesting time. Ladies and gentlemen, please do make sure that you watch this lesson from the beginning up until the end, as it gets more and more interesting as we are approaching, the end of this lesson. So guys, what I want us to discuss is the definitions, as you can see over there: change in momentum, impulse, and most probably, ladies and gentlemen, in the next lesson we might discuss problem types. Okay, that will be dependent on how long this lesson will take. Otherwise, if need be, I'm going to create another special lesson where I just focus on the problem types. In addition to that, we'll do just a few examples if necessary. So ladies and gentlemen, there's a learner who actually suggested that I include some notes in my lessons so that they are able to write. Okay, and also I think it was a good idea because it actually saves me a lot of time in terms of having to explain, write the notes, and give some relevant examples. So ladies and gentlemen, for this chapter I've prepared some notes of which I'm going to show you shortly. Then I will use this board to explain those notes. Again, if you're not able to clearly see on the screen, in case if this video is a bit blurry, ladies and gentlemen, you can just WhatsApp me on that number. This is a line which is specially meant for solving exam papers. 074 866 3830. So this is where you can just drop me a WhatsApp to say, I've watched that lesson and I need the notes. So I'm just going to quickly send you a photo of the notes that I'll be using in this lesson. Okay, so ladies and gentlemen, this means you don't necessarily need to write any notes, because I'm going to make them available by the end of this lesson. So you can just listen, ladies and gentlemen, write when necessary. In case if there's something that you want to emphasize or add to the notes that you already have, you can just write it down. But otherwise, for this lesson, ladies and gentlemen, I've prepared my notes. Okay, so guys, if you're watching this lesson on my website, www.solvingexampapers.co.za, you can just scroll down if you want to drop me a message, just in case if you are not on WhatsApp, or at the moment you don't have WhatsApp, I'm going to give you all of that information via email. So ladies and gentlemen, let's begin with the business of the day. Okay, definitions. Ladies and gentlemen, I've got some notes. These are the notes that I'm talking about. Okay, so ladies and gentlemen, what is momentum? It's very much important, ladies and gentlemen, that you understand what is meant by momentum. Okay, because without you knowing what is momentum, it won't be that much easy for you to continue with the lesson. Okay, so guys, momentum of an object. An object, obviously, ladies and gentlemen, it could be a tennis ball, it could be whatever which is in motion. Okay, and again, it also possesses a momentum when it's stationary, just like this marking pen, ladies and gentlemen. It's at rest, or it's it's stationary, it has a momentum. Okay, also when it's moving, ladies and gentlemen, it has a momentum. Okay, so a momentum of an object, of which in this example it was a monkey pen, is the product of its mass and velocity. Very simple, very quick, ladies and gentlemen. So let me just remove these notes and explain what is meant by momentum. Okay, so guys, as I've indicated, those notes are available. You don't need to write down everything that I write. Okay, so ladies and gentlemen, momentum is represented by letter P. Okay, so in physical sciences, when you see P, it is most likely to represent momentum. Okay, so do not expect momentum to be represented by letter M. Okay, so guys, I've just explained to you that momentum is the product of the object's mass and its velocity. Okay, remember guys, the word product, it refers to multiplying quantities. Okay, so in this case, we're saying momentum of an object is the product of its mass and velocity. Okay, so that means we're talking of two things, ladies and gentlemen: mass and velocity. Okay, so ladies and gentlemen, it's very, very much important that you note some of this information that I explained to you guys. Okay, so in short, since momentum is represented by letter P, okay, so that means momentum is equals to the product of the object's mass and its velocity. Okay, so that means momentum is equals to M multiplied by V. Okay, very, very much important, ladies and gentlemen. In some other textbooks, you might not have that dot, and you find that they say momentum is equals to mv. It's still the same thing, ladies and gentlemen. And again, in some textbooks, you might find that they say momentum is equals to m multiplied by v. Okay, so it's either you represent it this way, or that way. Okay, so ladies and gentlemen, it's very, very much important that you understand you've got two quantities, which is the mass and the velocity. Okay, and again, ladies and gentlemen, in some textbooks, you might find they've got this arrow at the top of P, and again they've got that arrow at the top of V. Okay, so that means it applies there and there. Very, very much important, ladies and gentlemen, that you take into consideration all this information that I'm providing to you guys. Okay, so ladies and gentlemen, what does it mean by that arrow? Okay, remember guys, we've got two types of quantities in physical sciences. Ladies and gentlemen, we've got a vector quantity and a scalar quantity. Okay, what is a vector quantity, ladies and gentlemen? This is a quantity that has both magnitude and direction. Okay, ladies and gentlemen, what is a scalar quantity? It's a quantity that has only the magnitude. Okay, guys, it's not a heavy weight. A magnitude, it simply refers to the size. Okay, magnitude simply refers to the size, ladies and gentlemen, or the amount. Okay, so obviously the difference between the two is that a vector quantity has got two things, which is magnitude and direction, whereas a scalar quantity has got a magnitude. I'll just give you an example, ladies and gentlemen. Time. You can never, guys, have a 2 seconds upwards. You will never have such a thing, ladies and gentlemen. You can never have 3 minutes eastwards. Ladies and gentlemen, you will never have such a thing. Okay, guys, you can never have 4 hours to the right or to the left. Okay, ladies and gentlemen, this is what we call a scalar quantity. Time has got only the magnitude, which is just 2 seconds, 3 minutes, 4 hours, or whatever, ladies and gentlemen. Okay, it doesn't have direction. That's why I've cancelled those directions, ladies and gentlemen. Obviously, I assume at this point in time you are aware that in physical sciences mostly we use upwards, downwards, eastwards, westwards, to the right, to the left, southwards, northwards, as a direction, ladies and gentlemen. Okay, so guys, I assume you understand that part. So now let's talk a little bit more about vector quantities. Ladies and gentlemen, in terms of vector quantities, obviously you know velocity is a vector quantity, which means you can have 2 meters per second upwards. Okay, this is what we call a vector quantity, ladies and gentlemen. You can also have what is it, guys? Just like I've indicated the momentum, so you can have momentum which is equals to, let's say, 4 kilograms per kilograms meters per second to the right. Okay, to the right. So you're going to learn some more in terms of what is a vector and a scalar quantity as we continue with our physical sciences lessons, ladies and gentlemen. Again, force is also a vector quantity, which means it has a direction and a magnitude. Okay, so ladies and gentlemen, things like mass, speed, ladies and gentlemen, these are the quantities which only has a magnitude. Okay, speed, for example, it could be 30 kilometers per hour. Okay, and again, mass, it could be 2 kg, 3 grams, or whatever. It doesn't have direction, ladies and gentlemen. So that brings us to this part. So that means in those textbooks where you see this arrow, ladies and gentlemen, if this arrow is at the top of that V, it means this is a vector quantity. You can see it's not there at the top of that quantity of mass. It means mass is a scalar quantity. So ladies and gentlemen, it's at the top of P, which means momentum is a vector quantity. So ladies and gentlemen, I assume with this information you are able to understand what is a scalar quantity, what is a vector quantity, and again, what is momentum. Okay, so ladies and gentlemen, before I bring those notes, let me just quickly explain to you the SI units of these quantities. So ladies and gentlemen, as you can see, a momentum I've just explained is mv. Okay, so obviously if I don't have a dot, if I don't have a multiplication sign, I've already explained to you that momentum of an object is the product of its mass or mass and velocity. Okay, so you can see momentum is actually made of two quantities on the right side, one quantity on the left. So mass, ladies and gentlemen, it's measured in kilograms. Okay, in physical sciences we measure the mass in kilograms. What does it mean, ladies and gentlemen? It means if you are given the mass in grams, please convert it to kilograms, ladies and gentlemen. Okay, so ladies and gentlemen, we've got a velocity. Okay, so guys, what is the SI unit of velocity? Ladies and gentlemen, it's meters per second, or otherwise, ladies and gentlemen, you can write this as meters per second. Okay, otherwise some they might write meters per second in that way. Okay, so it doesn't really matter that much, ladies and gentlemen, if you write the SI unit for velocity as meters per second in that way, otherwise in that way, or otherwise in that way. Okay, so ladies and gentlemen, I think it's very much important that I indicate to you this information, because you might find that someone who's in Limpopo, they teach them how to write the SI unit in that way. Someone in Eastern Cape in that way. Someone in Gauteng in that way. Okay, so whichever way I use, ladies and gentlemen, do not get confused. Okay, and also if you're using a different textbook, do not get confused. Just know that it's one and the same thing. Okay, so guys, what is the SI unit for momentum? Ladies and gentlemen, that means momentum, which is P. Obviously, guys, the SI unit for mass is kilograms. So that means it will be kilograms. Remember this mass was multiplied by V, which is measured in meters per second. Okay, so ladies and gentlemen, I normally use that symbol to represent the SI unit of velocity. Remember, SI unit, from time to time you'll hear me saying SI unit. So that means this is the international symbol unit of representing the velocity, which means internationally we represent the unit of velocity as meters per second. Okay, so that means if you're given the velocity, ladies and gentlemen, in kilometers per hour, ladies and gentlemen, convert it to meters per second. Okay, very, very much important, ladies and gentlemen. So please do make sure that you watch most of my lessons, because especially when I solve exam related questions, that's where I teach you how to convert. Okay, so ladies and gentlemen, I assume at this stage you fully understand what is the unit for momentum, what is the unit for velocity, what is the unit for mass. Okay, so ladies and gentlemen, let's now move on. So just bring those notes so that you are aware of where we are. So ladies and gentlemen, I've explained that part. I've also indicated to you that momentum is a vector quantity, which means momentum is in the same direction as the velocity. Okay, I'll explain that part shortly. So guys, I've also explained to you what are the units for the mass, velocity, and momentum. So now I just want to explain that part of the graphs. Remember guys, you'll be having these notes if you request them, and that's if you need these notes that I'm using to prepare for this lesson. Otherwise, if you just need to have them to add to the notes that you already have. Remember guys, I've just said momentum. Okay, it's in the same direction. It's in the same direction as velocity. Very, very much important, ladies and gentlemen. If we've got a ball, okay, if we've got a ball of, let's say, 7 grams, okay, and this ball is being thrown in that direction, okay, moving at a velocity of, let's say, 4 meters per second. Okay, so ladies and gentlemen, because this ball is moving in that direction, that means momentum will also be in that same direction of the velocity. Okay, why not in the direction of the mass, ladies and gentlemen? Is because a mass does not have direction, it only has a magnitude. Remember, ladies and gentlemen, so that is the reason why we say momentum is in the same direction as the velocity. Why the velocity? Is because the velocity has both the magnitude and the direction. Okay, so guys, I assume you fully understand that part. So ladies and gentlemen, let me now explain that part that I wanted to explain. So ladies and gentlemen, I wanted to say momentum, which is P, okay, is directly proportional to the mass. Very, very much important, ladies and gentlemen. The same momentum, guys, is directly proportional to the velocity. Okay, guys, this is how you represent this information that I've just explained to you in terms of a sketch or a graph. Okay, so when you see something like this, it simply means momentum is directly proportional to the mass. Okay, so in short, ladies and gentlemen, it means the more the mass of an object, the more the momentum. Okay, so you remember from the formula, ladies and gentlemen, you have mv. Okay, so it means the more the mass, the more the momentum. Guys, the more the velocity, the more the momentum. So that's why even here we say momentum is directly proportional to the velocity. Okay, so ladies and gentlemen, this sign, it actually means proportional. Okay, proportional. So that means the momentum is proportional to the velocity. So in this case, it's directly proportional to the velocity. In that case, is directly proportional to the velocity. Okay, just as an example, ladies and gentlemen, if we had something like P, that proportion sign 1 over, let me say, D, because my name is Desmond, ladies and gentlemen. So when you interpret something written in that form, you'll be saying momentum is inversely proportional to D. What makes it to be inversely proportional, ladies and gentlemen, is because of that 1 over D. Okay, but if it's just a P proportional to D, then it means momentum is directly proportional to D. In other words, ladies and gentlemen, in this case, it means the more D, the less momentum. But in this case, it means the more D, the more momentum. Okay, guys, I hope you fully understand what I'm trying to explain to you over there. Okay, so ladies and gentlemen, I think this brings us to the end of this part that I wanted to explain to you guys. So obviously, guys, that means if you have a momentum which is equals to mv, if we had 2 as the mass and we have 4 as the velocity, obviously 2 times 4 is equals to 8. Okay, so that means the momentum is 8. Ladies and gentlemen, if we add and have 3 kg as mass multiplied by, let's say, the same velocity, obviously in this case the mass is now, the momentum is now 12. So can you see, the more the mass, the more the momentum, the value of the momentum. If maybe we add here also, we have 5, then it's 3 times 5, which means the momentum is now 15. Okay, so can you see, the more the velocity, the more the value of the momentum. Ladies and gentlemen, let's now move on to the next part. I hope you fully understand that part, ladies and gentlemen. Remember, guys, for those who have got a WhatsApp, you can WhatsApp on that line for clarity. Okay, but I only attend to those who have watched my lessons from the beginning until the end, because I won't have to, spend much of my time explaining to you something that you haven't learned. Okay, so it becomes much better if you watch my lessons and you ask questions based on those lessons. Okay, you can just either send a text or a voice note. So ladies and gentlemen, let's now move on to that part. Okay, so guys, what is an impulse? Okay, impulse is the product of the net force acting on an object and the time that the force is applied to an object. So ladies and gentlemen, this is what I'm reading, ladies and gentlemen. So I'm just going to take off the notes and explain it to you. So ladies and gentlemen, these are the most important definitions or terms that you need to be aware of as far as momentum is concerned. Okay, so ladies and gentlemen, what I'm now talking about is called impulse. Okay, so ladies and gentlemen, I've just explained to you that impulse is the product. Listen to this very carefully, ladies and gentlemen. Listen to this very, very carefully. Okay, impulse is the product. So anything that starts with is the product. It means there's a multiplication sign involved, ladies and gentlemen. We are multiplying 2 quantities. So in case of impulse, what are we multiplying, ladies and gentlemen? Listen to the definition. impulse is the product of the net force. So ladies and gentlemen, we already have net force. Okay, so let me continue. Is the product of the net force acting on an object and the time that the force is applied to an object. So ladies and gentlemen, and the time. Remember guys, this thing is called delta. Okay, so delta is a Greek word, ladies and gentlemen. What does it mean? It simply means change, ladies and gentlemen. It simply means change. So the moment you see that sign, it means delta. Okay, delta, which means change. In short, what does change mean, ladies and gentlemen? Change refers to final minus initial. Okay, ladies and gentlemen, when it comes to time, just know that in physical sciences, you can always write the time as change in t. Okay, so in most cases, you'll just be given time, for example, as 2 seconds, 4 hours, 17 minutes or whatever. Just make sure that you convert it to seconds, okay? Because the SI unit for time in physical sciences is seconds, okay? Very, very much important, ladies and gentlemen. That's why, we've got delta T over there, of which I explained to you that it's change in time, or it's just time measured in seconds, okay? So that delta, ladies and gentlemen, if we've got delta P, this means it's change in momentum, okay? So if it's change in momentum, it means momentum final minus momentum initial, okay? Just like with time, it means it's time final minus time initial. But in most cases, you don't need to worry about knowing what is the final time or the initial time. Whatever time that you are given, it refers to delta T. Do not worry that much about understanding this part. You will understand it on my upcoming lessons. But if you do, consider yourself very, very much lucky. So ladies and gentlemen, I've just explained to you that an impulse is the product of the net force acting on an object and the time that the force is applied. Okay, so ladies and gentlemen, nothing to worry about, nothing to stress about. It's not that much complicated, ladies and gentlemen. So guys, remember the word product. Okay, so the moment you notice the word product, you know we've got some things multiplying with each other. Okay, so in this case, ladies and gentlemen, in this case, we've got the force multiplied by the time. Okay, so this thing is what we call an impulse. It's what we call an impulse, ladies and gentlemen. Okay, so obviously guys, we know the SI unit for force is Newton. Okay, we know the SI unit for time is seconds. Okay, so it seems like the SI unit for impulse, ladies and gentlemen, is actually equal to Newton second. Okay, it's actually equals to Newton's second. Still the same as Newton's second. Okay, so normally we just say NS, which means Newton second. Very, very much important, ladies and gentlemen, that you understand that part. Okay, remember guys, for this lesson is just a matter of me introducing you to the definitions or the summary of that chapter, momentum. So you just need to be aware of all of this information that I'm explaining to you. Okay, this is in preparation for exam related type of questions. Okay, so if you do not understand at this point in time, do not worry at all. When we get to that stage, when we solve exam related problems, that's where you will develop a full understanding. Okay, so ladies and gentlemen, let's now move on to the next thing. Okay, so let's see, ladies and gentlemen, we've got Newton's second law of motion in terms of momentum. Very, very much important, ladies and gentlemen, that you are aware of Newton's second law of motion in terms of momentum. Okay, so ladies and gentlemen, remember, I've just indicated that I'm going to emphasize more on what you need to be aware of. Okay, so guys, the net, remember guys, net means resultant. Okay, net means total, ladies and gentlemen. So it's either, in other textbooks they say net, resultant, or total. It's one and the same thing. It's one and the same thing, ladies and gentlemen. Do not get confused. Okay, so the net resultant force acting on an object is equal to the object's rate of change of momentum. Very, very much important, ladies and gentlemen. That last part is very, very much important. So that means Newton's second law of motion in terms of momentum is the net force acting on an object, okay, which is equals to the object's rate of change of momentum. Guys, remember, I've just explained to you what does the word change means. Okay, so let me just write it down. So now I'm actually talking about Newton's second law of motion in terms of momentum. Okay, so ladies and gentlemen, please note down that it's very, very much important that you understand Newton's second law of motion in terms of momentum, ladies and gentlemen. Okay, so we say is the net resultant force acting on an object, which is equals to the force which is equals to the object's rate of change of momentum. Okay, so remember guys, the moment we say the rate, the word rate, okay, it refers to something over time. Okay, remember, when I say time, I'm simply referring to change in time. Okay, very, very much important, ladies and gentlemen. So now that means from the definition that I've just explained to you, ladies and gentlemen, they say is the rate of change of momentum. Okay, the rate of change of momentum. With just that part, ladies and gentlemen, they're saying the rate of change of momentum. Okay, so that means, ladies and gentlemen, when you see this thing, it's actually the rate of change of momentum. Okay, what is this, ladies and gentlemen? This is the resultant force. This is the resultant force. Where is this formula coming from, ladies and gentlemen? It comes from Newton's second law of motion, but in this case, in terms of momentum. Okay, so guys, I assume you now fully understand that when we say the rate, we are referring to something over time. So if we say the rate of change of velocity, that means at the top you've got delta V. Why? Because we're talking about the rate of change of velocity. But in this case, we are saying the resultant force is the rate of change of momentum. Okay, sometimes they might say give the definition or state something where you might need to just explain that part, but in terms of weights. Okay, so remember guys, this is just an information that I need you to be aware of, not that you fully need to understand in just one lesson, or otherwise this is just to make you aware of everything that you need to know in relation to this chapter of momentum. Okay, so ladies and gentlemen, let's now move on to the second part of our lesson. Not necessarily the second part, but the next part. So now, where are we? We are on the law of conservation of linear momentum. So that means, ladies and gentlemen, there's a law of conservation of linear momentum, okay, which says the total linear momentum of an isolated, remember the word isolated means closed, okay, which means there are no any external forces, for example, okay. So the total linear momentum of an isolated system remains constant. So when they say in some textbook it's conserved, it simply means constant, okay. So ladies and gentlemen, this is some of the notes that you can write down or add to your notes. But one thing for sure, these are the information that your teachers have already taught you, okay. To say the law of conservation of linear momentum is the total linear momentum of an isolated system which remains constant. You will understand more of this as we continue with our lesson, ladies and gentlemen. So guys, the other thing that you need to be aware of is change in momentum, okay. So guys, when an object's velocity change in magnitude or size or direction, ladies and gentlemen, its momentum will also change, okay. Mass obviously remains constant or the same, but velocity is what causes the momentum to change, okay. So let me just explain to you that part, ladies and gentlemen. Remember guys, remember, change in momentum, it's obviously equals to, remember, just momentum alone, it's P, which is equals to mv, okay. But in this case, we've got change in momentum, okay. I've just explained to you that it refers to final minus initial, okay. What final, what initial? Momentum. So that means change in momentum, it's actually equals to momentum final minus momentum initial, okay. What does it mean, ladies and gentlemen? Obviously P is equals to mv, so I'm just expanding a change in momentum in a form of a formula. So that means it's mass v final minus mass v initial. Ladies and gentlemen, why am I not saying m final times v final minus m initial times v initial? It's because, ladies and gentlemen, the mass is the same, okay. This mass and that mass is the same, okay. So that's why I don't need to say final and initial. And most importantly, ladies and gentlemen, this mass and that mass is the same, but that velocity and that velocity may not be the same, okay. So that's why we specify to say mv final minus v initial, okay. So ladies and gentlemen, so we've got change in momentum based on what I've explained, ladies and gentlemen. I said when an object's velocity change in magnitude or size or direction, its momentum will also change. So that means the velocity, guys, the velocity has got a huge impact on the momentum, okay. So remember, momentum is equals to mv. So we are saying if an object or a ball is being thrown in that direction, okay, if at some point its velocity starts to decrease, okay, then it means its momentum will also decrease, okay. Ladies and gentlemen, if this hits the wall, okay, it hits the wall, it bounces in the opposite direction. Ladies and gentlemen, the same thing happens. Its momentum will change, okay. Very, very much important, ladies and gentlemen. So in this case, what I'm explaining is that its magnitude or size, okay. By that I mean, if at this point its velocity, maybe it's 10 meters per second, and somewhere there it's now, let's say, 7 meters per second, ladies and gentlemen. Can you see its momentum at that point, and that point has changed? Okay, that's why we're saying the magnitude of the velocity will change its momentum. Okay, or otherwise, in terms of direction, obviously if it hits a wall and it bounces back in the opposite direction, okay, so that means the momentum of that object has changed, okay, because of change in direction. Remember, it was going to the right, so now it hits a wall and it's now moving to the left. Okay, guys, remember, you just need to be aware of this type of information. Okay, you're going to develop an understanding when we solve exam related questions. Okay, so ladies and gentlemen, what else have we got? Let me just bring this so that you're able to see where I am. I've just explained change in momentum, ladies and gentlemen, which is when an object's velocity change in magnitude or size or direction, ladies and gentlemen. Remember, I can say magnitude or size. Okay, so in short, when an object's velocity change in magnitude or direction, its momentum will also change. It's as simple as that. Okay, so the mass, ladies and gentlemen, remains constant or the same. It's only the velocity which causes change in momentum. So let me just explain that part of the mass. So guys, that means the mass of this object, if its mass is 30 grams as it approaches that wall and hits the wall and bounces back in that direction, ladies and gentlemen, the mass doesn't change. It remains as 30 grams. Okay, this is provided that object, it doesn't break. Okay, so ladies and gentlemen, that's why we're saying on this formula of P, which is momentum, it's equals to mv. Ladies and gentlemen, the mass has got no impact on that momentum, because whether this object is moving in that direction or in that direction, the mass remains the same. Okay, but otherwise, in terms of velocity, you might find that obviously as it approaches, it moves at a speed which keeps on decreasing. It hits the wall, moves in the opposite direction, then its speed decreases. As it decreases, ladies and gentlemen, its momentum is now changed. Okay, as it changes direction, ladies and gentlemen, its momentum also changes in the same direction as the velocity. Okay, so guys, I assume you fully understand that part. Okay, so ladies and gentlemen, let's see what else we've got on our notes. We only study objects moving in straight lines, ladies and gentlemen. Very, very much important. So under this chapter, momentum, ladies and gentlemen, let me remove this information, ladies and gentlemen. Let me remove that part. Remember, guys, don't worry. If you haven't captured all of that information, it will remain available on this lesson. Okay, so you can just play this lesson over and over again. Otherwise, you can just drop me a WhatsApp text on that number, then I will give you these notes that I'm using. So we say we only study objects moving in straight line. What does it mean, ladies and gentlemen? If we've got a bullet, okay, if we've got a bullet moving in that direction, so ladies and gentlemen, it's either it moves in that direction, maybe you've got a wall and it passes through the wall in that same direction, ladies and gentlemen. Okay, so we are dealing with objects either moving to the right, or otherwise this could be moving in that direction, ladies and gentlemen, where you've got an object and again you've got a, what is it, let's say it's a block. Okay, so now let's say this is a bullet and this is a block. Okay, so ladies and gentlemen, you might find that this now bullet stuck inside that block and they move together. Okay, so ladies and gentlemen, they move in the same direction and they move to the left, or otherwise one can say to the right eastwards, one can say to the left is westwards. Okay, from that compass, you know, this is the east, this is the west. Okay, otherwise in terms of objects moving up and down, ladies and gentlemen, we are focusing on objects moving in straight line, straight upwards or straight downwards. Otherwise, one may say north or southwards, okay, from that compass, ladies and gentlemen. Okay, so ladies and gentlemen, we're not dealing with objects whereby there's a block and there's a bullet, it hits that block and it passes through, but when it passes through, you find that it's moving in that direction. Okay, it has to move straight to the right, okay, or straight towards the east, or straight towards the west, ladies and gentlemen, or straight upwards, or straight southwards or downwards. Ladies and gentlemen, that's what we mean when we say we only study objects moving in straight lines. Very, very much important, ladies and gentlemen. So guys, we're getting closer to the end of our lesson. Okay, so ladies and gentlemen, I think so far we've actually covered these formulas that I'm going to quickly explain to you guys. Okay, so let me just write down this information as part of our conclusion for this lesson. Okay, so ladies and gentlemen, the most important formulas. Okay, so ladies and gentlemen, as we started, we've actually noted that we've got what we call momentum, which is represented by P. This is equals to M multiplied by V, and the SI unit, the international symbol unit for momentum, is kilograms times meters per second. Okay, so this is the unit for the mass, this is the unit for the velocity. Okay, very, very much important, ladies and gentlemen. What else have we covered, ladies and gentlemen? Impulse. Okay, let's write it down to say impulse. Okay, so ladies and gentlemen, we've just noted that impulse, it's actually equals to the product of the force net multiplied by change in time. Okay, so ladies and gentlemen, we know the force is measured in newtons and then time is measured in seconds. Okay, very, very much important, ladies and gentlemen. What else have we covered, ladies and gentlemen? Remember, in terms of Newton's second law, in terms of momentum, we have noticed that the force net is the rate of change of momentum. Okay, it's the rate of change of momentum. I'm not really sure if you remember, ladies and gentlemen. So guys, remember, force is measured in newtons. Okay, force is measured in newtons. So these are the symbols for measuring the net force, impulse, and momentum. Okay, ladies and gentlemen, again we've covered a change in momentum. Notice the difference, ladies and gentlemen. This is just a momentum and this is change in momentum. Okay, so obviously change in momentum, this is momentum final minus momentum initial, which is equals to mv final minus mv initial. Very, very much important, ladies and gentlemen. Obviously, because it's a momentum, then it's measured in the same unit. Okay, so that means the SI unit is still kilograms meters per second. Okay, so guys, whether you're calculating momentum or change in momentum, you just know that the SI unit is kilograms meters per second. Very much important, ladies and gentlemen, that you understand what the question wants you to calculate. Okay, you might be requested to calculate the momentum of an object. Okay, you might be required to calculate an impulse. Okay, ladies and gentlemen, you might be required to calculate the net force. Okay, so obviously, guys, let me just explain that part by actually expanding it a bit. Okay, remember that formula, ladies and gentlemen, of force net. Okay, when we say change in momentum, we are simply saying momentum final minus momentum initial, all of this over change in time. Okay, ladies and gentlemen, this is v final minus v initial, all of this over time. Okay, so ladies and gentlemen, do not get surprised when you see a formula similar to this one, which is being equated to F net. Okay, remember guys, I've actually said something about the mass on this formula of change in momentum. Remember, all of this is just an expansion of that formula, ladies and gentlemen. I've just indicated to you that this mass is the same. Okay, so it means you can still write this formula as F net being equals to M into V final minus V initial, all of this over change in time. Why am I writing it this way, ladies and gentlemen? It's because there we've got a common factor. Okay, so I've just taken it out because it's the same. Okay, it's a common factor, it's the same value, it's the same magnitude. What differs is these velocities. Okay, that's why in brackets I've got velocity final and velocity initial. Okay, all of these divided by time. So ladies and gentlemen, so far these are the formulas that you need in order for you to be prepared to tackle any exam related type of questions. Okay, so ladies and gentlemen, on the next lesson I need to teach you on how to solve or approach or interpret questions related to momentum. Okay, but before we do that, I want to bring to your attention all the types of problems related to this chapter of momentum, ladies and gentlemen. I think it should be 5. Okay, so I need to teach you the type of problems associated to momentum. In that way, ladies and gentlemen, you just need to be aware of which type it is and you know which formula to apply straight away. Okay, so it's going to be an interesting one, ladies and gentlemen. As soon as I'm done introducing you to the types of problems, then we will solve or do a few examples, and then lastly we're just going to solve exam related questions. In that way, ladies and gentlemen, we'll be completely done with this lesson of momentum. Okay, so ladies and gentlemen, I assume you've enjoyed as much as I did. I'm trying to think if there's something that I've missed, ladies and gentlemen, but what matters the most, ladies and gentlemen, is for you to be aware of these formulas. It's for you to know where these formulas are coming from, and again for you to understand these formulas. Okay, very much important, ladies and gentlemen. So guys, I think I've actually said enough, so I'm not really sure if there's something that I need to add. Obviously, I've explained to you guys what is a vector quantity and again what is a scalar quantity. So what is it that I haven't explained, ladies and gentlemen? I've just said V, it's a vector quantity, momentum is a vector quantity, force net a vector quantity, change in momentum a vector quantity, and what else? It seems like that's all, ladies and gentlemen. So mass and time, these are scalar quantities. Guys, thanks very much for joining. I hope to see you on my next lesson. My name is Desmond, and I'm out.